Hello everyone, my name is Madhuri Desai. I'm a graduate research assistant here at Kennesaw State University and doing my research under Professor Yongshi. Today I'm here to give a presentation on my recently published paper, IoT Botnet and Network Intrusion Detection. We all know that with advancement in technology, there are more and more devices which are connected within the network, and most of them are the IoT devices. So these IoT devices are kind of susceptible to many different kinds of attacks, and one of the famous IoT botnet attack is a Mirai. So we know that there aren't only the Mirai attacks possible in the network because data before reaching to the destination has to pass through many different layers of TCP/ICP model. So they are exposed to many other kinds of attacks like MITM, DDoS, CAN, etc. Therefore, it is very important that these all kinds of attacks are detected, managed very well. And one of the possible way is here we are proposing is multi-class classification using ML models. There were a few researches which were already done in this area, but what different we are doing is here is we are using both IoT and network attacks into the same data set. It was before it was only limited to IoT or only the network attack. Here we are using both. As I told, we are using totally a new data set here, which is a network intrusion data set. It was downloaded from HCRL lab, which was created in 2019. There were different devices which are involved in the network. So they have captured 36 raw packets here. So since it was a raw data, we had to convert it into machine readable model format, which is which we have converted here into CSV format. For the conversion, we have converted into 115 features using count, covariance, etc. as the measure. So this is our approach here. We have used the network and Mirai botnet attacks, which were attached to the device, captured those network in raw formats, then feature extracted into CSV format. Then we did feature engineering, which is applying dimensionality reduction, PCA. Then we built the model and then trained the model, tested the model on different accuracies. So here we have used three different machine learning methods, which is decision tree, SVM, and RFC. All these models were trained on different criteria, like DT was trained based on different depths, RFC was trained on different estimator values, and SVM was trained on different kernel values. So all these data set, all these models were trained on 0.28 million records with 115 features, which were used from the feature extraction. Then we classified these records into Mirai, benign, MITM, and scan attack. We could see that DT and RFC were performing very well with high accuracy, while SPM was performing very low with the higher execution time. So we decided to go with random forest because it was having the highest accuracy with the lowest execution time, and the classifying of the attacks were very proper. So we went with the RFC model over here. Then we did PCA, that is dimensionality reduction. The purpose of doing PCA was, to reduce the training time basically, and the main motto was to maintain the accuracy while reducing the training time. We have applied PCA on RFC model because that was the model which we chose. We have used different dimensions here, right from 3 to 100. Then we have also conducted different experiments on this PCA, just not on the accuracy as a metrics. We have used different metrics, like we have done different ratios of data like attack skewed, benign skewed, and we have measured the performance of the model also using confusion matrix and precision and recall. Here we can see from this table that, like 0.28 million record, they have shown 35 minutes with 115 features, while when we used PC and reduced the features, it is showing just 6 minutes and 33, while the accuracy is quite maintained. So in conclusion, I would like to say that the random forest has been identified and was able to perfectly distinguish between the different attacks here with 99.97 accuracy. Multi-class classification using RFC has shown better result, while models like models like DT and SVM. The model was also tested on different ratios like normal skewed, attack skewed, etc. And also it was measured using the metrics like false positive detectives, etc. And also we have seen that principal component analysis does the better job in reducing the features with little to no compromise in the quality of the detection with the accuracy, as and we can see that it has greatly reduced the computational resources and also the execution time. Thank you.